Want to learn the technology that powers modern cloud applications and is one of the most in-demand DevOps skills today? In this video, you will understand how Kubernetes manages containers at scale and why it's essential for modern cloud platforms. So stay till the end, you will see how mastering Kubernetes can be a major career advantage. If you are in IT and still stuck in the same salary, not getting enough interview calls, listen carefully. Right now, there are two types of people. Those who keep waiting and those who upgrade their skills and move into high-paying roles, earning 15 to 45 plus LPA because the market has already shifted. Cloud, data, AI, DevOps. These are the roles driving real career growth today. At Coding Superstars, we have helped thousands of professionals move into top tech roles.
I got placed in IBEX Labs. Previously, my package was 8 lakhs. Now it is around 14 lakhs. Thanks for the Coding Superstar for the guidance, and the course is very worth it.
I have accepted a position as a DevOps engineer at NTI Mindtree. The skills which were taught by Coding Superstar were directly applicable to the role, and I'm confident that they will be essential for my success.
Recognized by Silicon India as one of the top 10 cloud computing training firms in India. People who once had zero coding experience are now working in top companies like Microsoft, Accenture, TCS, Infosys, and more. This is not just another course. This is your path to becoming industry ready. So watch this till the end.
We'll be starting Kubernetes from today. We'll be going through the Kubernetes, like what is Kubernetes, how it came into picture. So apart from that, once we learn everything in Kubernetes, the commands, everything in Kubernetes, then we'll be seeing the cloud Kubernetes as well. Like there are services in Azure, AKS, Azure Kubernetes services. Okay, we'll see after this. Okay, first we will be jumping into the enterprise Kubernetes, and we learn from enterprise Kubernetes, and then we'll jump into the cloud Kubernetes. If we talk about Kubernetes, Kubernetes is container orchestration software. It is container orchestration software. Now, what is this orchestration means? Orchestration means management. Okay. Orchestration means management. So it is easy to run one container, two containers, three containers. You can use Dockers, but when it is a fleet of containers, like 100, 110 containers, 200 containers, 300, it's a fleet of containers. So it is hard to manage those fleet of containers. Okay, it is hard to manage. Which container is coming up, which container is going down, or how many containers are corrupted. Okay, so how to heal them or bring them up. So manually performing this action is very hard. So for that purpose, they bring in one tool, which is Kubernetes. Okay, container orchestration tool or container orchestration software. So orchestration means nothing but the management. So container orchestration software it is, using which we can orchestrate or manage the containers. Kubernetes is an orchestration engine. Like Docker was an engine, so here Kubernetes is an engine. Okay. Using Kubernetes, we can orchestrate the containers. We can orchestrate the containers. Kubernetes is an orchestration engine. and also an open source platform. Also an open source platform. For managing containerized applications. It was initially developed by Google. Developed by Google. Later donated to. Later was donated to CNCF in 2014. So what is CNCF here? Cloud Native Computing Foundation. So sometime if you wanna perform or give Kubernetes certification, then you have to visit CNCF website. Okay. Cloud Native Computing Foundation. Cloud Native Computing Foundation. And here I write some history. Kubernetes version 1.0. 1.0 was released in July 21. Released in July 21, 2015. After it was donated to CNCF Foundation, they developed the version 1.0 and released it on July 21st, 2015. Before that, Google was using it. Since Google initially developed it, so before that, Google was using it as their internal development software. So before making it to public, Google was using, or before releasing the source code to public, it was internally used by Google. Okay. What are the features of Kubernetes? If we talk about features, so automated scheduling. First feature is automated scheduling. Advanced scheduling to launch containers on nodes based on resource requirements. Advanced scheduling options. Scheduling to launch containers on nodes based on resource requirements. Based on resource requirements. Okay, automated scheduling is first feature. Second feature is very important, self-healing feature. Okay, Containers do not self-heal in Dockers. Okay, they do not self-heal. So self-healing capability is there in Kubernetes. Self-healing, and from where it is coming from, we will see. Okay, self-healing capabilities. So self-healing means, suppose if any container dies, okay, so it will reschedule another container with the same everything, whatever is deployed in that container, with all that it will reschedule another container. So reschedule containers when nodes die. Nodes die. Suppose one node is running 100 containers and suddenly something happened to that node. What is node? Machine. Okay, because this is a master slave architecture. Kubernetes is a master slave architecture. There is a master and there are nodes. So master is the controller. Master is the controller, and it controls the deployments over the nodes. Okay, so if some of the nodes die, by any reason some of the nodes die, then it can reschedule the containers. Okay, so reschedule containers when nodes die. It can also kill containers when needed. So if anything needed or any situation like that, it can also kill containers when needed. Third is automated rollout. Rollout and rollback. Roll back. Okay, so what is automated rollout? So there is a built-in capability in Kubernetes, okay, of deploying the automatically managed like containers, automatically managed containers, and updating the process of versioning. So in Kubernetes, there is a built-in capacity. Built-in capacity of deployments. Deployments means whatever you are deploying in Kubernetes. Okay, so there is a built-in capacity of deployments to automatically manage the release and update process of application, whatever application you are deploying, application versions, as well as revert to previous version. if something goes wrong. Okay, so in Kubernetes, there is a built-in capability. There is a built-in capability of deployments to automatically manage the release and update process. So suppose there is a deployment done and there is a change in the image. Okay, so earlier there was some other image was used, and now there is some other image is being used, okay, for the new deployment. Okay, so what will happen? It will automatically replace the old deployment. Means there will be no downtime. So if we talk about any example, when updating a deployment by changing the image version, means earlier suppose version 1 was used, now we are using version 2 of that image. Okay, Kubernetes automatically replaces old pods with new ones. What are pods? So pods is grouping of containers. Group of containers is known as pod. Okay, group of containers. Which ensures there is no downtime. Means first it will bring up the new ones and then gradually it will take down the old ones. Okay, this is known as rolling update or automated rollout. Okay, the strategy is to perform automated rollout is called rolling update. Is called rolling update. So someone can ask you, what do you mean by rolling update? Okay, so it is a strategy. What strategy? Of automated rollout. Okay, the Kubernetes has inbuilt capability of deployments to automatically manage, release, and update process, okay, of the application versions to deploy as well as revert. Yes.
Kushal, is it similar with the blue-green update?
Come again?
Is it similar to the blue-green update, right?
Yes, blue green also can be called. It is a actually blue green is also a strategy only. Okay, rolling update is also a strategy, but rolling update comes under deployment. Okay, so deployment is nothing but it's an object. We'll just learn about the objects as well. Okay, so be patient. We are just in the start. So this I would have told in deployments only, but just for an so rolling update or recreate. Recreate is also a strategy. We'll discuss this later. Okay. So just for the example. And if we talk about rollback here, rollback. So rollback means if the deployment fails, if the deployment fails, so that means new pods, that is new pods crash or fail or fail the readiness check. So in that case, Kubernetes can detect the failure and automatically roll back to the previous stable version. Roll back to the previous stable version. So suppose the new containers or where you are performing the deployment with the new image, the container does not comes up. Okay, there is some issue. Okay. And while performing the readiness check of the container, Kubernetes detects that there is a failure. The new version is not coming up. So it will automatically roll back to the old one or the stable version. You can also manually trigger the rollback. You have the option to manually trigger the rollback as well. Trigger the rollback. So these are some features in Kubernetes which you will not get in Docker or any other software. This is Kubernetes famous for. Okay. Now let's talk about architecture. Kubernetes architecture. Kubernetes architecture. So it is a master slave architecture. It is a master slave architecture where master is the controller and slaves are the workers. Let's see. So here we are using user interface. Okay. User interface is using which you will connect to Kubernetes cluster. Okay. So this is your UI basically. Okay. And this is another CLI. Okay. So you can connect using two ways. Either you can connect using UI or you can connect using CLI. The CLI version of Kubernetes is known as kubectl. So we call it as kubectl. 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 Kubernetes command line interface. This is the master node. And these are the suppose worker node. So worker node 1, suppose this is worker node 2. Master node, worker node, and user interfaces. Okay, UI as well as CLI. Any you can connect through. This is CLI. Now comes inside the master node. What is inside the master node? So inside the master node, very first thing we have an API server. API server. Then we have scheduler. Then we have controller manager. Controller manager. And then we have etcd. Okay, etcd. It's a time series database. Okay, which maintains the information inside the Kubernetes master. etcd. First, I'll write down all the components, then we'll discuss. Okay, API server, scheduler, controller manager, and etcd. These are the 4 components inside the master node. Each one responsible for different. Now comes the worker node. So in the worker node, suppose there are containers here. C1, C2, and so on. Here also C1, C2. Here is suppose only one container is C1. Okay. Similar way you can take here C1, C2. C1, C2, C1, C2. These are containers. Okay, and the one containing the containers, okay, is known as pod here. So this is pod 1. Pod is grouping of containers. Pod is nothing but the grouping of containers. Pod 1 like this, then pod 2, this is pod 3, so suppose these are pods, okay, and inside the pod containers are running, but container cannot run without one component. How is container came into picture? So container came into picture using Docker only. Without Docker, container cannot run. Okay, so Docker should be there. Or apart from that, here kubelet, and then there is a kube proxy, kubelet and kube proxy. These components are here as well in another node or any worker node which will be created. Okay, these components will be there. Okay, a containerization software, a kubelet and kube proxy. So first thing here, kubectl is what? Kubectl is command line interface. Okay, it's a command line interface where you can connect to the cluster. You can give the commands, you can connect to the cluster. Command line interface. First thing, all the nodes here I'm talking about worker. All the nodes will have container runtime software, Okay, example can be Docker. Now let's discuss components in master. Okay. Components in master. So first was the API server. API server. API server is the entry point. It is the entry point for all the administration tasks. For all the administration tasks. Also known as front end of Kubernetes. Front end of Kubernetes. So kubectl is the command line interface which interacts with API server. Whatever command you will give, it will first go through the API server. Okay. With API server, when we give commands. After getting request from the API server, it will persist that request in etcd. After getting the request from kubectl, API server will persist that request. Means it will take that request and will go to the etcd. Okay. Because that has a database. etcd is a database, time series database. Will persist that request in etcd. Okay. What will be the kind of request? Request for scheduling a container, request for killing a container. So for any kind of request, it should have to go to the etcd because etcd is a database. Okay. Second thing, etcd maintains the cluster information. etcd maintains the cluster information please be in mute. etcd maintains the cluster information like nodes, pods, and services. So it maintains the information about these things. Third is scheduler.
ఏమో నువ్వు వస్తా అంటే ఆడికి వస్తా, లేదు అంటే నా మద్దతు పోతున్నా. నువ్వు చెప్పాలి అది నాకు.
Guys, please be in mute. Okay. Scheduler. Now what does the scheduler do? The scheduler will find the unscheduled pods. Scheduler will find the unscheduled pods. and will schedule them to the node and will schedule them to the nodes. So suppose there is any requirement. So scheduler will find if there is any request for the pod which is not created, it will talk to the kubelet. It will talk to the kubelet in worker node and then will schedule the pod. So once the worker node creates the pod, it will schedule the pod. Okay. So in worker node and then will schedule the pod. So this is the work of the scheduler. And then comes the controller manager. So fourth is controller manager. So controller manager manages the life cycle of the pods. If some pod dies, then it will schedule another pod with same components. Whatever is deployed in that pod, whatever is there, whatever application, software, whatever, okay, with all the same components, it will deploy. So that is controller manager. This is how controller manager controls the life cycle of the pod. Then comes the worker nodes. So these are components in master. Now comes components in worker node. First is worker nodes. Where application is actually running. Where application is actually running in Kubernetes cluster. Also known as minion. So if we talk about components in worker, so first component here is kubelet. So kubelet is a primary node agent. Whatever requests come from the master, it first is taken by the kubelet. Okay, it is a primary node agent. Any request coming in to worker from master will be taken care by kubelet. Like API server is the primary agent in the master, similar way kubelet is the primary agent in the node, worker node. Then comes the kube proxy. Second is kube proxy. It is also known as network proxy. Also known as network proxy. For all the networking inside the pods and the cluster, kube proxy is responsible. It is also known as network proxy. Since outer networking is not applied in the Kubernetes cluster. Okay, so in the cluster, inside the cluster, it has its own networking, and that is taken care by kube proxy. Like assigning the IPs to the pods, assigning the IPs to the containers. Okay, so that is done by kube proxy. So like the subnet or the VNet, it has an address space. Okay, so it has an address space. It will assign IPs to the pods and will make sure no same IP is assigned. No same IP is assigned. Means whatever IPs will be assigned to all the pods, they will be not the same. Okay, they will be different. Third is pod. So pods have the containers. Grouping of containers, or pod is a group of containers. You can say pod is a group of containers. Pods have the containers, or pod is a group of containers. So these are components in worker here. Okay. This is the architecture. Now let's talk about the installation mainly. Okay. Installation. We'll talk about Kubernetes networking as well. Okay. Later. Installation. First type is self-managed Kubernetes cluster. Self-managed Kubernetes cluster. Second type is managed Kubernetes cluster. Managed Kubernetes cluster managed by cloud providers. AKS, EKS, GKE, these are managed Kubernetes clusters, okay, managed by cloud. If we talk about self-managed, whatever architecture I have shown you, exactly as it is, okay, self-managed Kubernetes cluster. There are two ways to work with a self-managed Kubernetes cluster. Minikube. So this Minikube is a single node Kubernetes cluster. Single node Kubernetes cluster. Where manager is itself the worker. Manager is itself the worker. So whosoever is manager, the same is the worker. Okay. Only single node Kubernetes cluster. It is good for dev or test environments. Okay, for testing, developing, you can use this Minikube. Okay. Second type in self-managed is kubeadm. Using kubeadm, we can set a multi-node Kubernetes cluster. Multi-node Kubernetes cluster. Before that, I'll write something about self-managed here. Okay. So in self-managed, if a pod goes down, it will create pod automatically. It will create pods automatically. But if node goes down, any of the node, worker or master, you have to manually manage it. You have to manually manage it. Since you will be running this physically in a physical machine or in any of the virtual machine, you have to manually manage the master and the worker. It will only orchestrate. Orchestrate means manage containers and pods. Because you have to manually create some more instances, if physical machine or virtual machine. But the same is not the case with the cloud, because in cloud we have automated scaling. Okay, you have to manually scale here. But if we talk about managed Kubernetes cluster, managed means managed by cloud. In managed, if node goes down, again worker or master, it is taken care by cloud provider. That's why a lot of environments, like, they are moving towards cloud more. Okay, since it is very hard to manage a self-managed cluster, you have to manage the master. Something goes wrong with the master, you will be spending hours troubleshooting that. Okay, but that is not the case with the cloud or managed one. So in managed, if node goes down, it is taken care by the cloud provider. AWS, maybe Azure, GCP.
Abhishek, sorry to interrupt.
Mm-hmm.
I have one doubt. Actually, this OpenShift and Rancher are the managed Kubernetes cluster, right?
Aha, those I'll talk about that. Okay. So as of now, I'm just talking about Kubernetes cluster. Okay, there are third-party managers of Kubernetes clusters or enterprise Kubernetes. You can manage using Rancher. No issues. Okay, we are also managing on our side with Rancher only.
Okay. Thank you.
So as of now, I'm just talking about on the prospect of self-managed and managed. Okay. So in managed, if node goes down, worker or master, it is taken care by cloud providers. Okay. So like here we have in AWS, you can go with EKS, Elastic Kubernetes Service. In Azure, we have AKS, Azure Kubernetes Service. In GCP, we have GKE, Google Kubernetes Engine. Okay, like this. So if we talk about self-managed here, so I'll write down the requirements for C. If you are creating any cluster, a KubeADM cluster, okay, manually you are deploying as a self-managed. Okay, so requirements for self-managed. So first will be your master, and master will need like 4 GB RAM, 2 core CPU. Okay, 2 core CPU. One master, don't consider as this number one. Okay, one master, two workers. Two workers, and workers can have like 1 GB RAM, one core CPU. You can use.
Abhishek, so whenever we are creating a cluster, so can we have two master nodes? Like if suppose the
No,
loads are
master
more.
can be one now. Master can only be one.
Okay, okay.
This is just some like requirement I've given. And there is one more thing. Okay, when you are creating a cluster, you should always go with the ports. Okay, so I'll give you an example on ports as well. Like ports, which ports needs to be taken care. Okay, so 6443 6443 is for API server. Is for API server. API server uses 6443. Okay. Then 2379 and 2380 is for etcd. Is for etcd. Then from 10250, it is for kubelet, one zero. So when you will be setting up a manual cluster now, for that this information is okay. 10251 is for scheduler. These information you will get in Kubernetes website as well. Okay. 10252 is kube control manager. This is kube control manager. Kube control manager. And from starting from now you are deploying any application, so you can use from 30,000 okay to 32,767. Okay, these for node port services. Okay, these ports are for node port services. This is some port information. No one will ask that much deep, but just to. Okay. Now there is one more thing left, Kubernetes object. Like we have to start discussing the Kubernetes object. So I'll start discussing the Kubernetes object with the practical itself. Okay. So one object, there are 8 objects basically: pod, replication controller, replica set, daemon set, deployment, service, volume, and job. These are 8 deployment objects. Okay. Or Kubernetes objects, you can say. And each have a different meaning and different features. Okay. So we'll start discussing these objects one by one using practical. Okay. So now either we will be deploying this Kubernetes cluster, but if you deploy Kubernetes cluster, you have to engage 3 VMs. Mostly if you will go with the self-managed. Okay. I will not go with the managed as well. Okay. I will not go with the managed as well. I'll go with one thing here. There is a Kubernetes playground actually. Okay. So it is with Code Cloud. They have the Kubernetes background with them. Was just using it. There are a lot of others as well. Okay. But I'll show you just for practice purpose. Okay? You don't have to create the instances. And it is actually very good. I have used it. Pillar Poda. Yeah. You can just create your account. Okay. Already accepted. Okay, they are equipped with the latest one, like Kubernetes 1.32, and you can create one node cluster, you can create 2 node cluster. Okay, whatever playground you need to create, you can create with this, and you can just play with the commands. So this is like that. I'll show you in the next class. Okay, I have account in this. I'll show you in the next class.